Because I like recording myself. So in this case, we have 14x minus 2y equals 6, 6y, and 6y minus 9x equals 15. Now, by following substitution, we need to solve for a variable. And remember, in substitution, we always want to look for which variable has a coefficient of 1. Well, we don't have a variable that has a coefficient of 1. Can we still solve for x or y? Yeah, you could still say, oh, I want to do substitution. I like substitution. I am going to solve 14x minus 2y equals 6. I'm going to solve for y. So you'd subtract 14x, and you have negative 2y equals 6 minus 14x. Divide by negative 2. Divide by negative 2. Y equals negative 3 plus 7x. So you can still solve for y, right? But I just did all this work. Do you guys see all the work I did? It's not very easy, right? I mean, well, it's not easy. It's just very cumbersome. It's a lot of extra steps you have to do. If you do like substitution, though, you can absolutely do that. But I will advise you, sometimes you're going to get fractions where we know that we'll start making mistakes if we're using fractions. So the other method, especially that is really good to use when none of your variables have coefficients of 1, is elimination. And elimination, basically what we're doing is we are adding or subtracting our two equations. Kelsey, you need to find a seat over there somewhere. Move over there. Yeah, that's OK. I am. Move over there, please. So we're adding or subtracting our two equations. Now, if I add or we're adding or subtracting to eliminate a variable. If I add or subtract these, first of all, these are not lined up. So before I actually even do that, I want to line them up. 4x minus 2y equals 6. And let's rewrite this to negative 9x plus 6y equals 15. All right, so let's line up the variables first. Now, if I add or subtract these two equations, do I eliminate any of my variables? Do I get 0 as a coefficient by adding or subtracting? No. So that's a problem. So what we need to do in this case is you could either go back to substitution, or we need to find a common multiple for our coefficients. So we look at 9 and 14 and say, what's the common multiple of them? Or we look at 2 and 6 and say, what's the common multiple of 2 and 6? And the common multiple of 2 and 6 is?
2.
No, common multiple, the number they both divide into. Guys, multiples of 2. 2, 4, 6, 8, 10, 12. Multiples of 6. 6, 12, 18, 24. What is the smallest multiple that they share? 6. OK? So then all we simply need to do for this problem is multiply our top equation by 3 to get it to be 6, right? So now when I do that, I get 3 times 14, 28, which would be 42x. 42x minus 6y equals 18. Please note I'm applying distributive property across all of them. OK? Now I have negative 9x plus 6y equals 15. So now I have a negative 6y and a positive 6y. They're exactly the same. One's negative, one's positive. But to eliminate, to get that to be 0, should I just add the equations or subtract the equations? Add, right? So I'll subtract. It doesn't matter. You either want to do whatever operation is going to get that to be 0. So by adding them, I get 33x plus 0y, which is just 0, equals 15, 15, 33. Now I can divide by 33, and x equals 1. Now I know where they cross, which is x equals 1. To find y, though, however, I don't have an equation that solves for y. So I just need to pick one of the equations to plug it into. So Zach, which one? The top or the bottom? Doesn't matter. Bottom. So then we do 6y minus 9 times 1 equals 15. Now I have an equation with one variable. That's easy for me to solve, right? 6y minus 9 equals 15. Add 9, 6y equals 24. Divide by 6, y equals 4. So now I know y equals 4. That means these two lines, if you were to graph these, intersect at the point 1, 4. Does that make sense? OK. Now, the last thing I want you guys to understand is when you guys were graphing, we didn't always have graphs that